first thing I'm going to do is I'm just going to hide this utility blade. We don't need it for the 3D print. We're not going to be 3D printing the blade itself. And so I'm going to get rid of that. The other thing I'm going to do, at least on mine, is I don't want to 3D print this bolt here. So I'm just going to go back in time until before I added that bolt in. Like I said, you don't need to do that part. You should probably be at a point where you're happy with your knife as it sits. And I'm even just going to hide my fasteners too, just for the sake of simplicity. Now, maybe we'll do this a little more advanced. Maybe I will show you the fasteners, actually. And what we're going to do is, these are all brought in under this format here. And if I right-click on these and break link to all of them, I should be able to, let's see if it's going to let me, combine those into our main body. So if I select these three, cool. Now it'll join them all into this as a single body. I don't know if I didn't select this one properly. Let's find out. No, I just somehow had a double in there. I don't know what happened there. Anyways, so now I have these brought in as part of this, and that means that the 3D printer will 3D print these. So I'm going to stick with them there. So let's go ahead and talk about slicing this in half a slightly more advanced way. So for starters, it's the same way that we do in the other video. We're going to do the split body. And click on our body, and then click on our splitting tools, and click OK. And now we have two halves. So you got both here. And let's say that we wanted to locate these nicely as we glue them up. We can absolutely do that. It's pretty easy to do. We're just going to create a sketch. I'm going to put it on this middle face here. I'm just going to add, like, I don't know, 4 circles in the center, within the boundary of this shape here. And then I'm going to dimension them with my sketch dimension tool, all to be, let's just do 1.9 millimeters. Oh, looks like I'm in inches. I'm going to change my default here to millimeters real quick. And 1.9 specifically because we're going to use little cut-off bits of this plastic filament that the 3D printers use, which is 1.75 millimeters in diameter. And this is just a little bit bigger than that, just so that we have enough wiggle room in there to actually fit the filament offcuts into this hole. So I'm going to finish sketch and extrude. And I want a hole cut on both halves. So I'm going to turn visibility of my other half back on. I'm going to change my direction to symmetric. I'm going to go hole length. And then let's just do 10 millimeters maybe, centimeter. That's probably good. Just make sure it's not sticking out the side of your knife, whatever number you choose. But I think 10 mil is probably about right. And then click OK. So now if I hide this, I've got a couple holes in here. And then just to make it easy to slide the filament in, I'm going to chamfer the rim of each of these holes here. I'm just going to chamfer that out like 1.2 millimeters. No, that's probably too much. 0.8 millimeters. And then click OK. Mostly because when the 3D printer prints, like this is the face that sits on the build plate, and it kind of tends to squish out a little bit, and what we call elephant's foot. Let me show you what I'm talking about here. Has a tendency to, for the first couple layers, to be a little bit wider, which for a hole like that where the diameter matters, this would make the hole functionally a little smaller, and it would be harder to fit that offcut of the plastic into it. So that's why we're chamfering it. And I'm going to do the same on the other side here too. Oops. One thing you can do, rather than doing chamfer again, I can just turn visibility of this back on, and then I can double click that last chamfer that I did and just hide body 1, and then now I can select, by adding a selection set, these 4. It is a little confusing because it's already got them highlighted in blue because these occupy the same place as the other ones that we already did. But yeah, I'm going to go 0.8 and then just make sure that you got your chamfer on this side and then chamfer on that side. And then we can use those as little locator pins. So I'm going to hit save, and then let's go ahead and make a slot for the knife blade now. And this may mean that we're going to need to move one of these, and that's okay. I'm going to show you how to do that. So I'm going to turn visibility of this knife blade on, and then let me just open this up here. It looks like none of this has the little anchor icon on it, so that's good news, because if I hit combine and choose this as my target body, and then the knife blade as my tool body, and change it to cut and keep tools, and click OK. If I had the knife body, perfect. We got a little slot here where that knife blade was. So I'm going to turn visibility of that back on. I'm going to hide this half. I'm going to turn on visibility of the other half. And do the same thing on the other side. I'm going to choose the body, and then my tool body is the knife blade. I've got cut and keep tools. Keep tools just means that it's not going to delete this knife blade once it performs this cut action. And then like so. Now, one thing that I'm realizing is we probably want a little bit of tolerance if we actually want to have this this knife blade fit in our knives. So I'm going to go back in time to before I made those cuts by dragging my timeline arrow here. And I'm going to just slightly scale up. Maybe I'd be better off offsetting the faces. So let's just Windows select all. If you drag from right to left, everything that's within that window selection is going to be selected, including stuff that's kind of like hidden behind. So that's selected this half as well as this half, even though we couldn't see that backside before. And I'm just going to offset this like 0.1 millimeters, maybe 0.15 or 0.2, just to be extra safe here, just to make sure that we're going to have space for this to fit into your blade, into your handle, I should say, sorry. So now this is like a little thicker, a little larger than a standard X-Acto or utility knife blade would be. And that's purely just so that we have some tolerance and wiggle room there. So if I move back to, once I've done these, I'm just going to delete these. So I was here, I just offset faces 0.15 or 0.2 millimeters, and then went forward in time, and I turned the visibility of these back on. It's already recalculated for me with that offset. Even though we, in our physical world, in our timeline, I did that afterwards because I went back in time to before that and then made the change, and then went back in time or back to the future afterwards. It's updated that. And same goes for these holes here. So if I double click on my sketch here, because I have this hole and it's overlapping my knife blade, I don't want it to. So if I double click on my sketch here, I just drag my hole up a little higher and then finish sketch, it's going to automatically adapt for you. So really cool aspect of Fusion and other similar parametric modeling programs is that they update everything for you. That's what, at a very basic level, that's what parametric modeling is. It gets a lot more in detail, but for the sake of this, that's parametric modeling. So now I have a spot for the blade. That will fit in so that even once we stick both halves together here, we now have a slot on the front of this. And we have these little teeth that are going to hold the blade in place. And then these little holes are going to receive some little plastic pins that will locate the two as we stick them together. And we probably don't want to glue them together with a blade in there just because you have no way of taking the blade out once it's in there, so it's a safety hazard. But we can assemble and disassemble them just because we have some pins here to hold them in place. Okay, so we got both halves here. I'm going to save real quick just so I don't lose my progress. And I'm going to file and 3D print. Choose one half, and yours is going to export, and then you'll save it as your name, utility blade, half one, and then we'll import this afterwards to here. Actually, let me remove all this, and let me do it the way that you're going to be doing it. I have it set to automatically import to the slicing software, but I'm going to do it the standard way, which is the export. So I'm going to click on one half, click OK, and then I'm going to name this side one. Copy all that for second side. 3D print the other half. Side two. And then I go to my Elegoo slicer, and we're going to add our halves here. We're not going to load them as a single object with multiple parts. And then we are going to select one at a time. So I'm going to just click on one, and then click on the lay on face and select the flat face here. And then I'm going to select the other one, lay on face, and select that big flat face. And then I'm going to arrange all objects. Same button as up here. And then I'm going to click arrange. So now that's put both of my parts on the build plate. Oops, I did not mean to move that. Cool. And then we're going to use those the settings that I talked about in another video, but I'll walk you through them once more. Just for the sake of print time, we're going to change our wall loops to 2 instead of 3. And this is under your strength tab, by the way. We're going to change our bottom shell layers to 0. The biggest time suck when 3D printing is doing a full flat layer at a time, because it has to create such a long zigzag line to make it all. Whereas if we don't have a bottom layer, all it has to do is the outer rim and then some sparse kind of strings, which will end up being the infill. And then we're going to, speaking of sparse infill, we're going to change that to 10% just to make it print even faster. Mine is set up gyroid, which gives me this pattern. This is the one I like because it prints very fast, it's strong, and this should be the default if you're using my profile, but it may default to rectilinear from the built-in default settings from Elegoo Slicer, which is fine too. Okay, last thing is going to be supports. I'm realizing now this is a little bit of a complexity because of the the blade. So maybe we'll change this to just one bottom shell layer. So I'm going to hit enter and reslice that, just so that I'll have a flat piece for my blade to sit against. It's going to be very thin, but it'll be slightly cleaner. And then I'm going to go to my support tab. I'm going to enable support. I'm going to change this from tree to normal. Choosing versus tree and normal, probably like the way that I think about that is it a big flat area that I'm supporting? If so, I'm doing the normal supports. If it's a more organic shape or just a couple small points, I'll do the tree supports. So I'm going to do normal in the slice plate, and you'll see the green. The green means that's going to be where support's at. Oops, zoomed way in here. Just because it's a little like floating off of the build plate there. And then you're going to export your G-code file. Let's do Andrew. Advanced. And then you'll save this to your USB drive. I don't have one plugged in right now. I'm just going to put it on my desktop. And then you'll bring that up and we'll 3D print it. Okay, that was a long video. Hope that all made sense.